Good morning and welcome to AP Stats for March 18th. It is a Wednesday. Today we're going to talk about two sample proportions and confidence intervals, how we create them, what the process is. But the first challenge, of course, is the garment challenge of the day. Tell me, please, what my shirt says. You can comment in the section for comments, and it's kind of pertinent to our current situation. Now that our fun is out of the way, confidence intervals for two sample proportions. Here's what we're going to do. I'm first going to explain what we're trying to do and give you the equation, give you an example. Hopefully the setup is enough, and I'm going to assign maybe two homework problems so that you can practice it. Hopefully you did what I said and you brought your book home. Otherwise, you know, there are websites you can go on to find the textbook, whether they are legitimate sites or not. Comparing two samples. All right, so we're going to see whether two samples are going to generate for us a difference. For instance, rather than seeing if a sample from the population feels a certain way, and we can say whether the population will feel that way, we're going to take two different populations. So let's say a sample of men and a sample of women, and we're going to compare the proportions within each to see if they're going to agree with each other, not necessarily what the world of men or the world of women will say. Better with an example, as always. So here's what we want to find out. To make a confidence interval, we want to see if there's a meaningful difference between two sample results. Here's how it's done, all right? First, we have a little grid to create. So we'll have sample 1 and sample 2, and this will help organize our information. So for each sample, I want to know the sample size, the number in the sample who said yes, said no, whatever it is we're actually testing. Going to find the sample proportion of success, the sample proportion of failure for each one. It's going to help us organize our information. So here's the story. Let's say, and I read the prompt I created, is there a difference in the proportion of men and women who watch reality TV? To test that theory, we randomly survey 80 men and 100 women. All right, well, I'm going to call this men and this women. Just a cough, no corona. We have 80 men and 100 women. So the first bit of info goes in the grid. We find that 25 men and 40 women will actually like to watch reality TV. So that means that 25 of the men and 40 of the women said, yes, we watch reality TV. We want to find out if there's actually a difference between the two populations. So the request here is to make a 95% confidence interval for the population proportion that will differ, okay? So we're going to make a 95% confidence interval for proportions. All right, well, what's 25 out of 80? So what proportion of the men said they watch reality TV? That is 0.3125, which means that 0.6875 said, no, we don't watch it. Okay, well, the women, I have 100 as my sample size, so it's easier to find our proportions. That's 0.4 and 0.6. Just looking at the data, you could see that it's fairly similar, but there is perhaps some difference. 31.25% versus 40% in this case. Is it substantial? Is it significant enough to say that there truly is a difference between the two populations? Well, how do we find out? There's an equation we have to use. I'm going to squeeze it in here, and then because it's a whiteboard, not a Promethean, I'm going to have to erase stuff, but let's try to keep it still here. Okay, we have p hat 1 minus p hat 2. So the difference between the two sample proportions. Plus or minus, because it is still a confidence interval. Because it's proportions, we're still going to use z again. So there's a z critical, same as it always was. So the critical z-score for 95% confidence is still 1.96. And then instead of just the square root of the standard error of one sample, we have two samples to deal with. So it's p hat 1, q hat 1 over n1 plus p hat 2 times q hat 2 over n2. So I'll pause there, let that sink in for a little bit. Hopefully you can see everything. It's not a problem. P hat 1 minus P hat 2 plus or minus critical Z times the square root of P hat 1 Q hat 1 over N1 plus P hat 2 Q hat 2 over N2. That's the setup. And we already know how to plug in values. I'm not concerned about our abilities to substitute values and solve. I'm hopefully at this point not that concerned about it. So I'm going to leave the math steps up to you because I don't have very much room. I know you can plug in those values. I know you remember that critical Z-score for 95% confidence is 1.96, but if you don't remember, you know how to find it using inverse norm, where the area is 1 minus the confidence level over 2. And we're going to use 0 and 1 as the mean and deviation because we are normalizing to Z. What you get when you solve for these values is negative 0.2272 to positive 0.0522. Now I'm going to explain what that tells you. In this case, here's the explanation. We are 95% confident that the true difference between the population of men and the population of women who watch reality TV is between negative 0.2272 to positive 0.0522. Now, again, because it's the difference between two populations, a negative difference means that the second group watched it more than the first. A positive difference means that the first group watched it more than the second. 0 is in that interval. It spans a negative difference to a positive difference. That tells us that there's a 95% chance, if you want, or we're 95% confident, that 0 difference is contained within that interval. That means that our confidence interval is helping to see that there is no significant difference between those two populations based on our sample data. Are there conditions? Of course there are conditions. What are the conditions? Well, the same as they always are, except now there's two samples. We had to have randomization. So I told you in the beginning it was a random selection. That works. We have to know that our sample size is no more than 10% of our population. Obviously, there's more than 800 men and more than 1,000 women out there in the world who might watch reality television. We also have to have that NP and NQ being at least 10 rule satisfied. But this time it's for both samples. So NP of the men was 25, and that's more than 10, leaving the remaining 55 to be no's, that's more than 10 as well. The women had 40 yeses, which is more than 10, leaving 60 no's, which again is more than 10. These conditions, of course, have to be verified prior to moving forward with any test, just like every time. Okay, so that is the example that we're going to have here to base the work on. The work being on page 630, numbers 10 through 12. I'll write that down as well. But here is, again, the entire lesson for this part of the section. Confidence intervals will basically follow the same general rules as they did for one sample testing, but now there's two. So again, here is the recommended homework assignment, page 630, numbers 10 through 12. You guys should hopefully be able to communicate with each other. If you didn't bring your book home, try to text a friend. If you can't get a hold of one, you can tell me and I'll send you a picture of the textbook as well. Starting Monday, we're going to have attendance taken in some fashion. So here's what I'm thinking. I'm going to post, along with the video and any possible handout, I'm going to post for you an attendance sign-in sheet. You don't have to sign in at the exact same time as our class, but you have to sign in at some point, let's say before 2:30 in the afternoon, so that I can enter the attendance into Infinite Campus appropriately, and then no one yells at me for not doing my job. Sound fair? All right. Post any questions you have, post any comments, try to do the work if you can. Remember, I also posted the Chapter 9 test. Get that done before Monday. This homework should hopefully be done for tomorrow. I can't promise that I'll review every problem on the board, but if you want to comment about a problem you're having, I'll certainly write it out and send an additional video for the solution. Thank you very much. Have a wonderful day.